All right, folks, here is a lesson on trigonometric identities, okay? So I'm going to walk you through 4 examples, okay, where basically the problem will show you this, for example, on the left, this on the right, and you have to show the middle steps to get from here to here, start to finish. So you don't do anything to the finish, just tweak this using algebra to get to here. I think you guys did something similar last year, right? Okay. So let's look at the tools in the toolbox that we're going to use. Okay. So let's look over here. These 2 yellows you should have learned last year. Same thing with these. Okay. Cosecant and sine are basically inverses of each other. Okay. And then you have cosine squared plus sine squared equals 1. That is super duper important. Okay. You learned that last year? You seen that last year? Okay. And then you got these, which are less common, but still not rare. Okay. So here I can, for this, let me show you some variations of these. So this top right, I can rearrange to become these. Okay, just rearranging. All right. Here, I can subtract 1 from both sides and get tangent squared equals the secant squared minus 1. Are we good? We good on this orange right here, or that gray? Okay. I can also subtract 1 from both sides and get that right there. Okay. All right. I can also here switch, okay? I can switch the sine and the cosecant so that this yellow becomes that gray. I can square also everything here so that secant squared equals to 1 over cosine squared. Those are variations of this original identity, okay? All right, these identities are going to be tools in the toolbox to build these middle steps right here. So you can build these middle steps. Okay, that's how I want you to think about it. So now let's go over here. You can also square everything over here. Squared, 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 if you want. You can do that because they are all, this original identity is multiply or divide. Look, it's cosine divided by sine. So you can add squares to everything. If there was a plus or minus, for example, I made this one up, you can't just go squared, squared, squared. That will not work. Okay, that will not work. Okay. So some other things to note: keep, change, flip. If you have division of fractions, keep, change, flip. Okay. If you have a fraction with a similar denominator, you can rewrite it into 2 fractions. Okay, basically you have 2 terms on top, 1 on bottom. You can rewrite it into 2 fractions. All right. Now, now let's actually go through some examples. Now, let's look over here. Do you guys see how, so this is your original problem, and we're going to tweak this to get to the 1. We don't do any tweaking to the 1. Do you guys see how this cosecant became 1 over sine through this identity? Are we good? Do you see how secant became 1 over cosine through this identity? Yeah? Okay. Now, grays mean divide, so divide, divide. Keep, change, flip becomes this, blue, blue. Are we good, folks? Okay. What's sine times sine, everyone? Sine squared. What's cosine times cosine? Sine squared plus cosine squared is 1. Does that make sense, folks? Okay. Now, I'm going to subtract 1 from both sides. Okay. Tan squared is equal to secant squared minus 1. Do you guys understand this green identity here? Okay. Now, I told you can separate the fractions. Okay. Separate, so you get that because they both have secant in common. Basically, you have 2 terms on top, 1 on bottom. You can separate it with the term on bottom in both fractions. Does that make sense, folks? Okay. How many secants are left after canceling? 1. 1 over secant by way of this, okay, is equal to cosine. Are we in agreement here? Okay. Remember, you can switch secant and cosine. Okay. And so again, this equals to that through these middle steps. Okay. Now let's look here. I told you can add squares to both sides here, to each side. Do you agree that this green is going to equal to that green by way of this? You guys agree? Okay. Cotangent is equal to cosine over sine through this. Boom. Are you guys with me with green, gray, orange? Gray is division, so boom, boom, boom. I'm going to do keep, change, flip. Keep, change, flip. Are we good? Sines cancel after canceling. How many's left over? 1. 1 over sine is going to be cosecant. 1 over cosine is going to be secant. Does that make sense, folks? Okay. Now, last one. Let's look over here. Do you guys see how cosecant is related to 1 over sine through this pink right here? Okay. Now, right now, this looks like that. Are the denominators the same or different? Hold on. Let me show you like this. Do you guys understand how these two are equal right here? What's invisibly underneath this sign? A 1. Are the denominators the same or different for these? They're different right now. We want them to be the, okay? So I multiply this by 1, 1. That's kind of redundant. You don't need to show that. Do you understand why I multiply by sine here? Okay. All right. What's 1 times 1, folks? 1. What's sine times sine? And then now I can combine this fraction into this. What's 1 minus sine squared on top? Cosine squared. Okay. Now, do you see how this becomes that? Just you separating out the expanding the squared. Cosine squared, I mean. Are we good? Yes, no, maybe. Okay. I just expanded this to that. Okay. Now, what is cosine over sine? Exactly. And then we're done. Okay. So again, the original problem will show this is your start, this is your finish. Tweak the start, don't touch the finish. So keep tweaking the start until you get to the finish. Okay, that's how it works. All right. And in your worksheet, you'll have this as your tools in your toolbox that you use to get from start to finish. Okay. So when you do these problems, okay, I'm pretty much done with the lesson. Actually, yeah, I'm done with the lesson.